Dear students, today we are going to talk about radioactivity of nuclei, and we will also talk how many types the nucleus disintegrates. Well, what is radioactivity? Spontaneously, there are certain unstable nuclei which spontaneously decays or disintegrates into some lighter product, or in some cases the product mass may not vary, but still it radiates some light, that is gamma rays. So invariably in all these type of decay, something is emitted by the nucleus. So that is called, the spontaneous disintegration of nuclei is called radioactivity, and it happens in three ways, namely alpha decay, beta decay and gamma decay. Well, here we are having all these three decays compared side by side, so that it becomes very easy for us to keep it now in our memory. Well, what is alpha decay? In case of alpha decay, doubly ionized helium particle, means 4 mu or 4 units of mass having 2 positive charge, means helium having no electron. So that is called alpha particle is radiated. In case of beta decay, in this what happens, beta particles means electrons or positrons. We name them together as beta particle. Either it could be electron or it could be positron. So means the charge on electron is negative, but having same mass, charge on positron is positive, but it is having the same mass as that of electron. And in case of gamma decay, there is emission of photons, that is electromagnetic waves, which are gamma rays, and therefore we also call it gamma decay. Well, in this case, the nuclei remains in the same state, but it only switches from excited state to de-excited state. Now we can have some nuclear reactions. For an example, we say uranium-238 92 atomic number is disintegrating into thorium-234 90 atomic number, and in addition to that, after this decay, it emits alpha particle, and also some heat energy is released. Well, in this case, in case of beta decay, what happens? A neutron emits electron, converts it into a proton, and emits one electron and some antineutrino particle, plus some heat is released. If we consider emission of positron, then in that case what happens? It becomes instead of electrons, it is positrons are emitted, and instead of antineutrino, the neutrino is emitted. Some heat is also generated in this case also. An example of thorium-234 atomic number 90 is converting into Pa-234 atomic number 91, plus 1 electron is radiated. Here minus sign indicates it is electron, and antineutrino, plus some heat is released. Now in case of gamma decay, what happens? We take a typical type of disintegration in which cobalt-60, cobalt-27 atomic number is disintegrating to release beta particle, plus nickel 60 atomic number 28 in excited state. Now in the second stage, this nickel gets de-excited in a time of 10 to the power minus 9 to 10 to the power 14 minus 14 seconds, and then while it de-excites, it loses energy which appears in the form of gamma rays. Now what happens in general when alpha decay happens? The atomic number Z is reduced by a factor 2 and the atomic mass A is reduced by a factor 4, because you see helium is having 4 units of mass and 2 protons are there. Therefore Z reduces to Z minus 2, A reduces to A minus 4. While in case of beta decay, what happens? Z increases by 1 factor and A remains unchanged. Here you see one neutron is converted into proton. So atomic mass remains same, but atomic number is increased by 1. And in case of gamma decay, there is no change in atomic number, no change in atomic mass, because only the nuclei is converting itself from excited state to de-excited state, and equivalent amount of energy is produced in the form of gamma rays. Now we talk about the speed of the alpha particles after obtained from alpha decay is about 7% of the speed of light in vacuum, and that is nearly equal to 2 into 10 power 7 meters per second. While in case of beta decay, the beta particles emitted due to the beta decay is nearly 90% of the speed of light, and that comes out to be 2.7 into 10 to the power 8 meter per second. Now gamma ray is nothing but electromagnetic wave, so speed is equal to speed of light in vacuum. Ionizing power of the alpha particle is highest and its penetrating power is the lowest, because alpha particle is doubly charged while its mass is much big, so it is having lowest penetration, and greater charge, therefore it is having highest ionizing power. The beta rays, the electrons are having moderate ionizing power because it is having only 1 unit of electronic charge and its mass is also small, therefore its kinetic energy is small, therefore it is having moderate ionizing power and moderate penetrating power. In case of gamma rays, the ionizing power is very least, nearly no power exists with it, and higher it is having the highest penetrating power. Now we talk about half-life. Alpha particle is having a half-life of the order of 10 power minus 6 seconds to 10 power 17 seconds, few billion years. And the half-life of beta particles, that is electrons, is very very large, 66,000 into 10 power 24 years. And the gamma rays are having the life as electromagnetic waves have, so it is very very large. Now the charge possessed by alpha particle is twice the electronic charge. Its kinetic energy is about 4 million to 10 million electron volts. For beta particle, the charge is either equal to 1 electronic charge or equal to the charge of a proton, that is positive charge. And kinetic energy of beta particle is of the order of 0.019 MeV to 3.3 MeV. So this is the kinetic energy. Usually it depends on what type of nuclear reaction is taking place, that will decide what is the kinetic energy of the emitted beta particle. Same thing is valid for alpha particle decay. What type of nuclear reaction is taking place, that will decide that what is the kinetic energy carried by alpha particles emitted due to alpha decay. Now the gamma rays are having no charge, and their kinetic energy are very few MeV, of the order of 1.2 MeV, etc. Now since alpha particle are positively charged, therefore it will be affected by electric field. It will be, if it is in motion, it will be affected by magnetic field. Similarly, electrons are having charge or positrons are having charge, therefore it will be affected by electric field, and if it is in motion, it will be affected by magnetic field. But gamma rays are nothing but electromagnetic wave. It is having no charge. It is therefore it is not affected by the electric field, or it is not also not affected by the magnetic field. However, all these, be it alpha particle, be it electrons, or be it the gamma rays, all are affected by gravitational field. That's all for today. Thank you and have a nice day.